Now, if you have a system and you have a data set of the inputs and outputs of this system varying over time, is it possible to quickly figure out what model best describes it? Now, this is the question we set out to answer with Cybernetica Modeller. Determining what model describes a system is obviously very important. For instance, the system could be an industrial plant that you wish to control more profitably or safely, and to do so you would need to understand it well. Now take as an example a system with only a single input and output, and with a set of historical data as shown here. What model best describes this data? We can start with the simplest possible model, which is a stationary relationship between input and output. And as you see, the resulting model does match data somewhat, which indicates that there is a relationship between input and output, but the model is not very accurate, so we will get back to this. Before we continue though, keep in mind that the true test of a model is how well it fits data it has never seen before. And that is why we partition the data set we get in 4 different ways and find 4 models for the same set of data, as is shown here. The grayed out areas shown are sets of data that are excluded from the fitting and is used only for validation. Now, the 4 models are drawn as black, magenta, green and red here, while the dataset is in blue. Now, back to our example. Where do we go from here? Firstly, we clearly see that there is a dynamic response in the output that the model does not capture. So that motivates including a history term, which makes the model a difference equation. Now, to do this in Modeller is simple and quick, and we can re-identify quickly. Secondly, we now see that we have a model which is a better fit, but it is still slightly off in its ability to match stationary gains. So we try adding a curvature term to describe these gains more accurately. And we re-identify, which improves the model even more, as we see. Thirdly, we see that there is a delay between the system and the model of 5 time steps, and so we include this in the model and re-identify. Now, this was a simple example, but Modeller is capable of describing quite complex systems with many inputs and outputs and with nonlinearities. The software includes a wealth of plots designed to compare and help in finding the best model, and to assess uncertainty in this process. Also, once modeling is finished, the model found can be exported at the press of a button. So, to answer our own question, you can find a model describing the system using only data, and we did so here in a matter of minutes. Crucially, the structure of the model found is very similar to what you would expect to find with a first principles model, and it's on differential equation form, and it's very well suited for an online application.